6.1 Angles of polygons. The diagonal of a polygon is a segment that connects any two non-consecutive vertices, meaning ones that are not next to each other. For example, in that polygon PQRST, there are two diagonals. If I start at vertex P, I can draw from P to R and from P to S. PQ doesn't work because they're next to each other. PT doesn't work because P and T are next to each other. So what this does is actually separate my polygon into 1, 2, 3 separate triangles. I have one over here, one over here, and one over here. By knowing how many triangles it separates it into, I can tell what the sum of all the inside angles are. For example, we know that a triangle is going to add to 180 degrees. We can't draw diagonals in our triangle, though, because there's no vertex that's going to be non-consecutive, right? These guys are next to each other. These guys are next to each other, and these bottom two are next to each other. In our triangle, we know we have 180 degrees as well, which is important. With our quadrilateral, from this point, I can only draw one diagonal, so that gives us two triangles. This triangle has 180 degrees in it. This triangle has 180 degrees in it. With a pentagon, a five-sided figure, we have two diagonals that can be drawn. Again, we have one triangle here with 180, one triangle here with 180, and one last triangle here with 180. With a hexagon, a six-sided figure, I can draw 1, 2, 3 diagonals. That separates this into 1, 2, 3, 4 triangles. There's 180 degrees here, 180 here, 180, and 180. So this is going to help us lead into a formula. Now this has 3 sides, 4 sides, 5 sides, and 6 sides. So since the sum of any of the angle measures of a triangle is 180, we can really, get a special formula for this. So a triangle has 3 sides. There's only one triangle drawn in the triangle because I have no diagonals. So they add to 180. With the quadrilateral, which has 4 sides, there are 2 triangles. So 2 times 180 is going to give me the sum of all of the angles, which is 360. In a pentagon, a 5-sided figure, there are 3 triangles I can draw. So I'm going to get 540, 180 times 3. In a 6-sided figure, there's 4 triangles. So 180 times 4, which is 720. So in general, if I have n number of sides, any number of sides, that means I can draw n minus 2 triangles, right? 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So I'm just going to multiply by 180 times n minus 2. And that is going to give us how many degrees should be on the inside of my shape. So the sum of the interior angle measures of an n-sided, however the number of many sides is, convex polygon is n minus 2 times 180. So the number of sides minus 2 times 180. So we can use this theorem to do a few things for us to help find missing measures or missing values. So first we want to find the sum of the measures of the interior angles of a convex heptagon. So all of the names of our common polygons are listed here. A heptagon has 7 sides. So now we're just going to use this formula. So there's 7 sides to a heptagon. So that just means 7 minus 2 times 180. 7 minus 2 is going to give us 5. So 5 times 180 is going to give us 900. So that means the sum of all of the interior angles is 900 degrees. Same kind of question here. We want to find the sum of the measures of the interior angles of an octagon. Octagons have 8 sides. So we're going to do 8 minus 2 times 180, which is really going to be 6 times 180. And when I multiply 6 times 180, I am going to get 1080 or 1080. We can also use it to find measures, not just the sum, but to find missing parts. So in this, we see that we have 4 sides. We have a quadrilateral. That means that all of the angles inside need to add to 4 minus 2 times 180. 4 minus 2 is 2 times 180. So we need to add to 360 degrees. And that is really the total for the inside. Okay. I look at this and I see those boxes in B and C. That means there's 90 degrees there and there. So just like when I'm finding the missing angle in a triangle, I can add up all of my angles. It's just this time I set them to 360. So I have 3x plus 90 plus 90 is going to equal 360 degrees, the total interior sum. Now I can just add these together. So that's 4x plus 180 is equal to 360. Subtract 180. So 4x equals 180. And when I go to divide, x is going to equal 45. Now we want to find the measures of each. So that just requires us plugging in. So if x is 45, angle D is going to be 45. And if we have A is 3x, so 45 times 3, that means that angle is going to be 135. And we're just plugging this in for x. We can do the same sort of thing here. We see that we have a 1, 2, 3, 4, 5-sided figure. So let's find the total. That's 5 minus 2 times 180. So that's going to give us 3 times 180. And 3 times 180 is going to give us 540 degrees. So that's the total interior number of degrees. How many inside? So let's add them all up and set them equal to 540. So we have 2x plus 142 plus 2x plus 3x plus 14 plus another 3x plus 14 has to equal 540. Whoops. Okay. So 2x, 2x, 3x, 3x is going to give us 10x. 142 plus 14 and 14 is going to be, I believe, 170. Let me just double check. 142 plus 14 and 14. Yeah, 170 is equal to 540. We're going to subtract 170 from both sides. So we're going to get that 10x is equal to 370. And when we divide by 10, we're going to get 37 for our x. So now we can plug that 37 in to find our missing angles. So we can do 37 times 2 for the 2x corners. That means this one is 74, and this one's also going to be 74. And then we can plug into that 3x plus 14. So 3 times 37 plus 14 is going to give us 125. So we just replaced x with what it was equal to. All right, we can find the number of sides when we are given an angle measure. So the measure of an interior angle of a rectangular polygon is 135. We want to find the number of sides of that polygon. All right, so if the measure of one interior angle of a regular meaning all the sides are congruent and all of the angles are congruent, meaning all of the angles are the same. So each individual angle is going to be 135 degrees. So what we can do first is take the total, right? N minus 2 times 180. And if we divide that by the number of sides, that's how many angles there are. That would tell us how much each angle is worth. So we know that is going to equal 135. And now we can just solve for n to figure out how many we should be expecting here. So we'll multiply by n on both sides. So that gives us 135n. And then it's up to you. We could distribute or divide. I'm going to distribute. So that's 180n minus 360 is equal to 135n. We're going to subtract 180 from both sides. So that's 135n minus 180n. So we get negative 360 is equal to negative 45n. And lastly, we will divide. So negative 360 divided by negative 45 is going to give us that n is equal to 8, which means we have an octagon. Okay. We can do the same thing for the next one. So again, we see that word regular, meaning all the sides and the angles are the same. Each individual angle is 144. So if we take the total sum of the angles, n minus 2 times 180, and divide by the number of angles, which is going to be n, which is also the number of sides, we'll set that equal to the 144 for each individual angle. All right, we'll multiply by n. So we have n minus 2 times 180 is equal to 144n. Then we can distribute. That's 180n minus 360 is equal to 144n. We can subtract that 180n from both sides. So we're going to get that negative 360 is going to equal negative 36n. And then we will lastly divide. So we're going to get that n is equal to 10. So that means we have a decagon. And you could always go back and look at the chart for those names. And then we have the polygon exterior angles sum theorem. So the idea is if I were to extend each of the sides of my shape, I would get an exterior angle, an angle on the outside. And we've seen exterior angles before, back when we were just doing triangles, and we knew that if we added these two angles together, then we would get that exterior angle. So that's nothing new, but we are using it with more than just a triangle. So you want to notice that the sum of the exterior angle measures in each case is 360. So 120 plus 100 plus 140 gives us 360. If I do 105 plus 40 plus 110 plus 105, again, I get 360. And same over here, 65 plus 111 plus 50 plus 36 plus 98 is going to give us 360. So the rule is that all of the exterior angles are going to add to 360, no matter what the shape is. So let's take a look here. We know that if I add all of these together, they equal 360. So 2x minus 5 plus 3x plus 10 plus 6x minus 5 plus 2x plus 5x is going to equal 360. And it just says to find the value of x, but we could always find the angles if we plugged back in. So 2, 3, 6, 2, and 5. So 2 and 3 is 5, 11, 13, and 18 for x. And let's see, negative 5 and 10 is 5. So minus 5 is 0. So I think we just get that 18x is equal to 360. So that means that x is going to equal 20. All right. And lastly, we want to find the measure of each exterior angle of a regular, remember all the angles are the same, dodecagon, and our dodecagons are 12-sided. All right. We know that all of the exterior angles are 360. So if there are 12 sides, there are 12 exterior angles. So it's just 360 divided by the number of sides. So 360 divided by 12. And 360 divided by 12 is going to give us 30. So each of those angles is 30 degrees.